Hello everyone. I'm going to go over today's agenda, explaining what to do not only today but also the whole week. So this is the agenda for today. We have a very short Zoom meeting, particularly for taking attendance. That was the main idea of today's Zoom meeting. And you had three main assignments that will be due on Sunday. You need to finish the post-test on Edmentum, the Unit 3 post test. By clicking on this link, it will take you to the submission. Don't forget that you have to post a screenshot of your result, and that will be the way I will be posting on the gradebook. There also will be, in total, will be 6 questions that you need to answer on Canvas. And the questions have, the first question had three questions. Just you need to answer. Okay, I'm going to main letter because I'm not going to give you any suggestion. You say the answer for question one. You just reply and type a text that will be R, P, and Q. And the same thing with the question bonds second part. That will be for the first one. For the second part, you also do the same thing. You had three answers and you say W, X, Y. Of course, there is no any item with the R and W or P or Q. It's just making a letter, so there will not be any suggestion for you on this one, okay? So that's the first thing on the thing pending. Those things are due on Sunday at almost midnight, 11:59 on 10/25. That will be the due date. Let me make sure I had that will be the due date for that. So the next thing will be working on the moles and molar mass, and I'm going to give you a short explanation. Unit 4 is already open, mole concept on Edmentum. And the first thing that I'm going to do, let me see if I can get my eraser so I can have more room for writing. And I'm going to erase this thing here because I don't need that anymore. And I have more room for writing on the unit number 4. That will be this one. Okay, here it is. Moles and molar mass. Let me start here. Mole, we define mole with the lower n. That will be the symbol that we use for representing mole. And don't forget the following: 1 mole of any substance will be equal to the Avogadro number. Avogadro number will represent capital N and a lower a at the bottom, and that will be equal to 6.02 times 10 to the 23. For instance, in water, we will have 2 mole of atoms of hydrogen. So we need to multiply this number by 6.2 times the Avogadro number. If there is any question that asks you how many mole of atom do we have in water, on hydrogen in water, that will be 2 times 6.02 times to the 23. So that's the first thing that you need to know for the first definition of mole. The next one will be molar mass. What is the molar mass of? Let me give you an example of that. If you need to find the molar mass of water, you need to do the following. You need to multiply the number of mole of atom, which is 2 here, times the atomic mass of hydrogen, plus then 1 time, because you have 1 mole of oxygen atom, times the atomic mass of oxygen. Where I can find the atomic mass? Looking at the periodic table. That will be 2 times 1.00 gram over mole. That will be the atomic mass listed on the periodic table. And this one will be 1 times 15.99 gram over mole. Why 1? Because I only have 1 atom of oxygen in 1 mole of atom. So this one will be 2.00 plus 1 times 15.99, and you just need to do the addition of this one, and that will be 17.99 gram over mole. Sometimes we can round this one to 18, and that's also okay if you do that. So that will be the molar mass of water. What is the molar mass? Adding together the every single atom in the formula and multiplying by the number of moles. I mean, multiplying first and then adding. That will be the correct way to do that. So there is a relationship between mole and molar mass, and I want you to take note of this formula. It's a very useful formula. That will be number of mole will be equal mass of the substance over the molar mass. Let me give you an example of that. If I ask you, or if I tell you, how many mole do we have in 36 grams of water? Just do the following. How many mole in that mass? It will be equal mass of water over the molar mass of water. And that will be equal to 36 gram, which is the mass of the water, over 18. I'm using the rounded value for the molar mass. And if I do my calculation right, that will be 18 goes into 36 two times, because by multiplying by 2 will give me 36. So I have 2 mole of water. Notice that I'm talking about 2 mole of water molecule, not 2 mole of hydrogen or 1 mole of oxygen, 2 mole of the whole molecule. Again, let me make a record. Please take note and write down this formula. This is mole. This is mass. We express mass in gram or kilogram, it depends. And this is the molar mass. Take note of this one because this is a very important formula. So the next thing will be, well, this is mole calculation. And this is the mole calculation. Percent composition. What is the percent composition? Percent composition of any substance I will call X substance in a formula XY will be equal to the mass of X over the mass of Y times 100. That will be the percent composition. For instance, if I want to ask you, what is the percent composition of hydrogen in water? That will be one question. I will write mass of hydrogen over mass of water and times 100, of course. And then you will do the following. Mass of hydrogen will be 1 time, because I had 2 hydrogen, 2 times, because I had 2 hydrogen, atomic mass of hydrogen, and the mass of water will be 1 time the molar mass of water, and that will be 2 times the atomic mass of hydrogen will be 2 over 18. I forgot to write the 100 here, but don't forget it will multiply by 100 times 800. And I use this side here, percent composition, because I don't want to write erase all the thing that I wrote already. So 2 over 18 times 100. So that will be 1 over 9 times 100. And let me do the calculation quickly. My calculation will be dividing 1 over 9. That will be equal 0.11, 0.011 times 100. My answer will be, I have 11.11% of hydrogen in water. And that's the way you do percent composition. And last but not least, the empirical formula. Now I'm going to erase everything I wrote because I need more room for writing on the empirical formula. I think I got the right, clear canvas. Then I need to paste again the yeah, that will be the today agenda. So let me move to the center and make it bigger. Yeah. So the next thing will be empirical formula, molecular formula. Let me get my pencil here. What is the difference between empirical and molecular? Empirical formula is the least ratio of the combination of atoms in any molecular formula. For instance, in let me write the molecular first. In benzene, which is an organic compound, the real molecule has 6 atoms of hydrogen combined with 6 atoms of hydrogen. But the empirical formula will be the small ratio, so we can simplify this formula. I can divide by 6 and divide by 6, and the empirical formula will be 1 to 1. 1 atom of carbon times 1 atom of hydrogen. Let me give you another example. In hydrogen peroxide, we had 2 hydrogen per 2 oxygen. We can simplify by dividing by 2, and we get that the empirical formula for hydrogen peroxide is HO. But again, if we have sodium chloride, there is no way it's already 1 to 1. We don't need to simplify. So notice that in the case of sodium chloride, the empirical formula equal the molecular formula. The same happened with the water. Water, we had 2 hydrogen and 1 oxygen. We cannot simplify more, so the empirical formula will be this one. So anyways, empirical will be the small ratio between the atom in the one compound, and the molecular one will be the real full substance with all the atoms, the presence of all the atoms that exist in the molecule. And what is the relationship between empirical and percent? Well, if we use the percent, we can find empirical and molecular formula because we can convert percent to mass in any formula. I can give you later one example of that. And then using this formula, again, the famous formula that I say, write down, we can find the number of mole of the substance. Using this formula will give me the number of mole, and that will be a quick way to find the empirical and then the molecular formula depending on the problem. So that's all I have for this week, and particular for today's agenda. And I will be sharing this explanation with you in a moment. Thank you for watching. Bye now.